8-5. This is talking about proportions in triangles. Just one more proportion that you can find. The stuff particularly in this lesson has to do with when you have a pair of parallel lines in the triangles. So please use your own words so that it makes sense to you. Something called the side splitter theorem. You don't need to write it down exactly how I say it. I'll explain it. Basically, if there is a line inside the triangle that's parallel to one of the sides, if a line inside a triangle is parallel to one of the sides. So what I'm talking about here is this line right here is drawn inside the triangle and it's parallel. That's what those two markings mean. If it's parallel. It only works if they're parallel. Then the side parts, right? The little parts on the two sides that it's cutting up, and I'll call them the split sides. That's why it's called the side splitter theorem. Are cut proportionally. If I'm looking at the particular triangle I have right here, that means A over B is the same as C over D. Very handy when solving problems to know, as long as those are parallel, that A over B is the same as C over D. So there's something else that's called the corollary to the side splitters theorem. It's the same idea, except it doesn't matter if the two sides connect. If I have any two sides, right, those would eventually make a triangle if I connected them all together. And I draw two parallel lines. They do have to be parallel. And actually I need a third parallel line because without a top on the triangle, let's see. And note that it doesn't have to be right in the middle of them. Right, there's just three parallel lines. That the little sections are still proportional to each other, even though it's not a triangle. I still have a little A and a little B and a little C and a little D, and A over B equals C over D. So a diagram and the equation for the corollary. It's the same idea, just know that like the two parts don't have to be parts of a triangle. They could just be in between parallel lines. Next one, the triangle bisector theorem. Write it in your own words. Okay, if one angle of a triangle is bisected, so that means cut perfectly. So this angle, if that's, say, 50 degrees, this is also 50 degrees, this angle right here, right? It's a perfect cut, the angle. Then it divides the sides, the sides will be proportional to the corresponding, I'm not saying this very well, easier to actually give you the equation. This side the percentage that it cut off of the base is proportional to how it compares to n. The equation would be m over p is n over q. If the triangle is bisected, it cuts the opposite side, so like the side with P and Q, in pieces proportional to the adjacent, right? P goes with M, the adjacent, the ones right next to, triangle side. You'll have to kind of come up with your own words to make that work, but M over P is the same as N over Q. They're proportional to each other. If M had been bigger, that's why P is bigger, N is smaller, and if it had been smaller, then Q will be smaller. They're proportional to each other. If M is twice as big as N, then P is twice as big as Q. That's basically what that says. I'm going to do just a couple examples. So, example. I have a right triangle, and a line was drawn. Okay, so first of all, you should realize you cannot use the special things in this lesson unless you have parallel lines or an angle that has been split in half. In this case, there are parallel lines because you have corresponding congruent angles. Those lines have to be parallel because both of those were 90. If both of those had been 80 degrees, they'd be parallel. If both of those had been 30 degrees, they'd be parallel. As long as the angles are the same, the sides have to be parallel. So they give us more information than this. They said that the top little section is x plus 1.5, and the bottom on the left is x, and this hypotenuse is 5, and this hypotenuse is 2.5. So to write out our equation, the two parts, it's like x plus 1.5 over x, is the same as 5 over 2.5. I did top over bottom, so I have to do top over bottom along that hypotenuse as well. I find the extremes, so 5x equals 2.5x plus, let's see, I don't know what 2.5 times 1.5 is off the top of my head. It's the same as what, 15 quarters, so 37.5. Subtract 2.5x from both sides. That gives me 2.5x is left, and a positive 37.5. How many 2.5s fit in 37.5? I really should have grabbed a calculator. Let's see, there's 4 for every 10, so that's 12 plus an extra 3, so 15 equals x. That decimal place is not in the right spot. That's what I get for doing mental math. That should be 3.75, not 37.5. 3.75. 3.75, which would give me 1.5. There we go. Sorry. All right, so one more example. As you might have guessed, I'm going to do one that's cutting an angle in half. I'm going to put the angle right side at the top to make it as easy as possible. So I was trying to draw that line so that these two angles were the same. I'm going to say I don't know this, but I know the entire length is 14, and that this is 10, and this is 15. Okay, so the thing you have to remember about the angle splitter theorem is that you need this and this. Those ones go together. And this and this. You will notice they didn't really sit it up for me nicely because I have nothing along this blue section on the bottom, and I need there to be. So what we do know is that 14 goes all the way across the bottom, but the first part of it's x. That means 14 minus x is the part that we were missing. Now I'm ready to do the problem. 10 over x is 15 over 14 minus x. So getting my extremes, 15x equals 140 minus 10x. Do make sure the 10 is distributed to both items. So I add 10 to both sides. That gives me 25x equals 140. Come on, Longo, how hard was it to grab a calculator? Okay, so 140 divided by 25. Do this by hand. That'd be 5. Be 125. That'd be 15 left over. 6. So 56. Except, is there a decimal sum in there? Yes. So x equals 5.6. So that should pretty much get you through that lesson.